Hey everyone, welcome to Zero Shot Learning, a podcast about the reality of developing with AI from the people actually doing the work. I'm Nancy Wang, and I'm the Chief Technology Officer at 1Password. Normally, I co-host this show with Dave Tagare, who's a Senior Director and Head of Engineering for Gemini Enterprise and Business at Google. But today, I'm joined by our very own Jeff Malnick, who is a Vice President and General Manager of Developer and AI at 1Password. Our guest is Maxim Fateev, who is a co-founder and CTO of Temporal. Before Temporal, Maxim was a tech lead at Amazon, where he helped break their monolith architecture into microservices and co-authored the AWS Simple Workflow Service. He then went to Uber, where he co-created Cadence, an open-source workflow orchestration engine. Maxim is widely recognized as a pioneer of durable execution, which was a revolutionary shift in software development. Before, if a server were to crash mid-task, the application state would be lost, and you had to build your own recovery logic or even start over. Durable execution preserves the full execution state automatically, so complex tasks resume exactly where they left off. Maxim built Temporal to bring that property to the broader engineering community. Temporal is empowering global engineering teams build highly reliable distributed systems. Their open source orchestration platform has become the backbone for AI development, serving as a foundational execution layer that allows complex, multi-step, autonomous AI agents to reason, persist, and run reliably without state loss. This is a super fun episode. Stick around after the interview for a demo of their chatbot agent generating code, but he's abstracted away the different backends. He switches between Python to Docker, from local to remote environments. You really have to see this. So lock in. This is Zero Shot Learning. Well, hello, everybody. Welcome to the Zero Shot Learning podcast, where we have the pleasure of sitting down with some of the most cutting edge builders in the AI world today.
Hey, everyone. I'm Jeff. I'm the Vice President, GM of Developer and AI at 1Password. Been at 1Password for about 5 months. Previously, I was lead engineering at HashiCorp for the Vault, Boundary, and Radar products.
Wow, awesome. We're joined here by Maxim Fateev today, the co-founder and CTO of Temporal. Welcome, Maxim.
Thank you.
Yeah. And I just want to say, today, of course, as more enterprises are deploying agents in production, it's not just sort of a one task, right, or a simple chatbot function. We're now expecting agents to do long-running workflows, things like, for example, even what we're building internally at 1Password, for example, an AI SRE agent, right, that needs to be able to understand state, store state, be able to do retries. And so in that world, right, something that you've always talked about, which is agents are bringing back, distributed systems. Like, tell us more about how you got the inspiration to start Temporal, right? Maybe drawing from your Amazon as well as Uber days.
Yeah, I worked I kind of as engineer grew up at Amazon, and I led quite a few projects. And most significant was at least initial big one was PubSub platform. We call it Amazon Messaging Platform. It was broker-based architecture, but it was created like beginning 2000s, so it's well before even Kafka and all these handling technologies were conceived. And all backend of Amazon practically ran on that. And later, when AWS appeared, Simple Queue service needed a storage engine, so they took that and ran with that storage engine. I don't know what they do now, but at least for the first 10, 15 years, they were using that engine. So as an engineer who was practically responsible tech lead for all PubSub of Amazon, I talked to practically every team because Amazon was one of the first companies doing services at large scale. When I joined, they actually had a monolith. It was kind of amazing. You could run the whole Amazon website on your desktop. Wow. The catch was that just to relink that binary was taking up to 45 minutes on a high-end developer desktop. And it was in full, I think full rebuild was like 18 hours in the backend system. So breaking mainline wasn't, we had actually wiki pages or something. I broke mainline and like practically text, like it was bad. and practically we did what everyone is doing now. We moved to event-driven architecture for the backend, and I was talking to all those teams, and it quickly became clear that PubSub is just not the right way to stitch together complex systems. And Amazon always relied on orchestration, and initially it had orchestrator on top of Oracle, kind of Petri nets based. Then they did another one, and my team, which won PubSub, decided to work on the orchestrator practically at that point. And there were multiple attempts, and the first attempt ended up being public version of a simple, like first public version of a simple workflow service at AWS. I was tech lead for that, and co-founder of Temporal, now CEO Summer, was working with me on that. And initially we were very focused on backend part of that, how to kind of do orchestration, how store state, all of that. And we did multiple, and we were trying to figure out what's the right experience for developers for that. And we tried all the traditional approaches. We did like graph-based, and we did some other permutations of that. And at some point, I just didn't like them because they're always very verbose and hard to program and troubleshoot. And it wasn't like one aha moment, but it took a few iterations to realize that you actually can just write code. And that preserve full state of like normal code execution, not some intermediate representations like abstract syntax tree or graph. And that was a kind of big revelation, and here's how this idea was born. What we call now durable execution.
Would you say that that was like a principle or recurring architectural theme that kept coming up over time there?
Yeah, the theme is that when you have event-driven architecture, you still implement workflows, right? Like if you still have sequences of steps, you still need to execute operations based on whatever external outputs. So you have a flow, again, not fixed flow, right? It can be super dynamic flow, but it is a flow. So it's all about calling services in certain order, right? And reacting to events. And when you use event-driven architecture, you practically end up in a situation when this logic is kind of spread out everywhere. And there are no APIs, because what is the API of a service which consumes 10 types of messages, produce 25 types of messages, right? Like API, my state machine is my API. Usually the state machine is not very well defined, and it's like there is no API there. And some people, I know there is kind of, I think API spec, right? But they spec messages, not APIs of services. Another part is that I tend to say that there is big confusion in the industry about, at least people who are not directly involved, is that people say that event-driven systems are loosely coupled. And they always example, you can add new service, and that other parts of the system don't need to know about that, right? Because it can just consume messages. I can give you example.
Well, actually, that's a great maybe segue to talk about what are some examples of coupling cohesion, right? So on the back end side, that's often what our principal engineers talk about when they're designing systems, which is which ones do you want loosely coupled? Maybe give us some examples.
Yeah, okay. You want is loosely coupled always, right?
Of course. Yeah.
Where possible. But problem with event-driven systems is that there is big confusion between runtime and design time, right? They're absolutely loosely coupled at runtime, right? The whole idea of them, because I think system, by definition, you don't need synchronous invocation is so stateful that anything fails, right? You get slowed down in the whole system, error propagates, and so on. I think system allows your service to keep functioning even if other services are not functioning because there are queues in the middle. So this is very useful in production. So your systems are loosely coupled in production. Problem is people make this assumption, they are loosely coupled in design time, which is not true, because you change the format of the message in such a system, like who's broken. I don't even know which service can be broken by my change. And in a lot of cases, just not even format of the message, maybe order of the message, or maybe something else changed, right? So there is this messages flying around, and you change anything and things can break anytime. So design time coupling of the system is immense. They practically always end up being. I can give you example from other areas just to make it more concrete.
Sure.
Imagine you get your engineer and says, you know what, our service is so coupled. I want to make it more loosely coupled, right? So I will go and change all variables to global variables. Why? Because now I can add new piece of code, and this new piece of code can read those variables, right? and and other pieces of code don't need to be changed.
I think I know how
But-
this ends.
But this is exactly the logic people use when they say I can add a new service in the event-driven world, right? Yeah, I can read variables, but it doesn't mean that it's loosely coupled, right? So yeah, and this is what I say, that events are global variables of distributed systems.
One of the things that I'm hearing you talk about is you describe this journey of discovering these new workflows and how to get engineers to engage with distributed systems. It sounds like you were thinking deeply about developer experience, right? Like you went from this state of pub sub architectures to one where you're designing a workflow-based system in code. Just talk a little bit about like how that thinking evolved and how the developer experience and like making it more seamless for people to interact with these really complex systems kind of evolved for you.
It's clear that we want orchestration for a lot of these systems. The problem always was that you always had a choice. You either use your code, your tools, or you go and write orchestrator, which usually some sort of state machine and usually with some sort of domain-specific language. And it's not, unfortunately, it's not actually domain-specific language, which there is huge confusion as well, because the whole definition of domain-specific language means it's for a specific domain. For some reason, a lot of people assume that workflows are domain. Workflows are just a very general purpose thing because everything is a workflow technically in the backend, right? Like your infrastructure deployment is a workflow, right? Your agentic agent is a workflow, or even if super dynamic one, right? And your business transaction is a workflow, and almost anything like your data pipeline is a workflow. So almost everything is a workflow.
Yeah.
And but what it means that we are trying to come up with general purpose programming language in JSON or XML or YAML or pictures, right? And then it always ends up a bad contraption. Because by definition, like there is a reason there are top-level programming languages. If JSON was better, we would just program C kernels and like Linux kernel and other things in JSON because it was just better way to do that. But for some reason, people say, no, I want a picture of my, like I want a JSON or the DAG for workflows, but I don't want them for anything else. For me, it sounds like copying. Okay, I have to do that. That's why I will say it's good. And the whole idea of kind of we come up with, which we call durable execution, that you don't need any other language. You can just use Java. And it's not like sometimes people also confuse, say, we do workflows as code. And for example, Airflow says we do workflows as code. Yep. But what Airflow does, Airflow code generates DAG, and then what actually executes is DAG, right? And Airflow actually, actually for Airflow it can make sense. Why? Because for data pipelines, DAGs are very frequently reasonable, and they are in this case it's a domain specific because domain is data pipelines. But problem is then that people take Airflow, try to use something dynamic. And they're like, I cannot add a node in runtime, so I will generate this DAG in runtime, and then it becomes a mess, right? So that is a problem. But then you can use just Java directly and run normal Java code or like Python, TypeScript, whatever, and that make this code durable, right? And I think it also takes people realize what it means durable. It means that this code cannot fail at all, right? Like so you call an API, your process crash, reply to that API can come 3 days later. You resurrect that process in exactly the same state, still blocked on the same API call, give it result, it keeps running as nothing happened.
Yeah.
So
well, that's a checkpoint, right?
It is check, but from developer point of view, it's not checkpoint, right? From developer point of view, your code just blocked for 3 days, right? Behind the scenes, how it's implemented, it's there are different ways to do that, and checkpointing is not the only one. We actually don't use it.
Oh, okay. Tell me more about that.
Yeah, we use replay.
Okay.
So we practically record the results of all external operations, like side effects. And then you need to resurrect that function. We just give it results back. And if code is deterministic, it ends up exactly the same state. So there is no, because you cannot checkpoint, you technically can checkpoint code, but you need to go pretty deep into the operating system, memory. But what we do it on practically as a library to Java, for example, or Go. We don't change runtime. We don't own runtime. It is just normal library. And you cannot, on a library level, take JVM and ask it to snapshot something which is blocked on a synchronous API.
It's actually a really clever way of solving it. So I spent about 10 years designing a backup software. And so that's a system that, a lot of what we just talked about, like the ability to retry, kind of checkpoint, more on the logic side of, when, for example, to take a snapshot of this EBS volume, right? Where to store it, where to tier it, when to hydrate it. So in that system, I'm curious, drawing from your Amazon experience, what were you looking to specifically improve with Temporal?
I think our goal was improve developer experience,
Mhm.
right? Because, as I said, when we started, we had like two alternatives. One is you use traditional method, pops up, or just databases or cron jobs, practically stitch all these things together. And then other option was more like traditional workflow engines, which had two problems. One is, as I said, developer experience was based on these kind of configuration languages, which stop working after certain complexity. The probably very well-known example is BPMN, right? It's a standard. And for some reason, the standard didn't evolve for like the last 20 years. And the reason is that promise of the standard and idea is actually very good, that we want a non-technical people write these workflows, and then they just do these pictures and everything magically runs. A result was that non-technical people cannot write them. They can maybe see the picture, but they cannot really write it to the point when it's actually production executable. And then developers have to deal with that. The problem is that picture represents only sequence of steps, and not always well, and for dynamic scenarios just doesn't work at all. But 90% of complexity of workflows and any program is data. It's like variables, data mapping, input, outputs, state management, your data structures. None of those visual languages represent any of that. Okay, some of them kind of try to do that, but then it's like, end up with 10,000 lines going all over.
It's sort of like you have to read between the lines as a systems engineer.
Yeah.
You still need to have a lot of domain expertise.
Yeah, and then there are like a lot of like lower technical details. Most of them don't have strongly typed APIs. They have just notion of a task, and like even BPMN, if it calls a task gets a map, like a hash map, and can update that hash map. So practically it's a global variables map which any task can update. So talk about loosely coupled system, right? Because which task, if something breaks here because variable is not there, right? Like this value is not there, which task updated that? Looking at this picture, you're not going to see that. You practically need to go back in Java code which implements those tasks and see that. So practically going back to what we are trying to solve, we were trying to solve for developer experience and scale. Right? Initially we started on scale because we started at Amazon, and anything at AWS by definition should scale practically infinitely. And we spend a lot of time doing backend service which scales and provides capabilities which are required for that. But at the same time, we were iterating on developer experience, and we are trying to come up with something which would be the best. And first attempt was okay, right? That's why most people still don't know about simple workflow service. It wasn't good enough for actually pick up steam.
So maybe then pivoting the conversation to agentic workflows, right? I mean, we firmly believe with you or agree with you that everything becomes a systems problem at the end of the day. And so in the world of, building agents and long-running workflows with agents, like maybe walk us through how you think about it when failure modes happen, right? Is it with the model or is it with the agent logic? Like, and how do you discover that?
I think, it's you need to have a system working end to end.
Sure.
But if you think about how all these applications started, and they're still mostly in that mode, like look at Cloud Code or like Codex CLI, they're just in memory, some in-memory program which makes synchronous RPC calls, right? And yes, MCP kind of a little bit asynchronous, but technically still very stateful, very synchronous thing. And it kind of works if you have just one application running on your machine and making those calls. But the moment you say, I will have a lot of them, things change completely, right? And also long running change things completely, because a long running automatically assumes, and not even long running. Think about you want it complete. You don't want to just go and die in the middle, right, and lose everything. So you say, I wanted these agents survive failures, for them just process restarts. But then you call a tool, and tool is not available. You need to retry, right? Mm-hmm. The moment you start retrying, short call becomes long call.
Yes.
Right?
Yep.
Because and then you can decide how long you want to retry for 5 seconds or 5 hours or a day. But conceptually, the moment you went from short synchronous invocation to I need these things to complete, you automatically make it long running, right? And then a lot of things starts happening there because, okay, what if I have 10,000 of those things calling that thing? And all of them are hitting that, right? So we will overload that. So we need exponential backoffs. But even if you have exponential backoff and you have a lot of callers, you have so many requests, even with exponential backoff hitting that thing, it will be overloaded. So you need flow control. The moment you have flow control, you need a queue. Yes, at runtime, you need a queue. And then you need a rate limit. And all these things starts adding up, even if you have simple synchronous processes calling. But then this process can be long running and we need to recover their state. So you start thinking about state management, recovery, snapshotting. And a snapshot is not enough. For example, there are quite a few, I think, agentic frameworks just provide snapshotting. And people take the framework, all good, I will run with that. And then they realize that if your process crashes, snapshotting doesn't help. Because even if it was snapshotted, you need to figure out that process crashed, right? So you need to have something like Heartbeat or some system around that which will discover things which failed. But if your process contained not one agent, but 10,000 agents, how are you going to find which agents should be recovered? Right, so all these things, you start putting them together and you need to solve all of them. And I think people just who started from, synchronous Python and memory program, I think they're kind of learning hard way that these are not simple problems.
Yeah, I remember, you built a swarm of agents, right, as a example of what we could build internally to, for example, debug production databases. Can you talk about that and maybe frame it in what Maxim just went over as in when agents fail, how do you know actually which agent failed and how do you kind of retry?
Yeah, my background, my domain of expertise, I worked at Mesosphere back in the day, so I have a bit of a distributed systems background. But for the last 10 years, I've been focused a lot on identity security. And one of the interesting things with agent swarms when we were trying to get this system off the ground was how do we actually bootstrap identity for 1,000 agents that are going to all be working towards a single mission? And that's not necessarily an easy problem to solve because just like you were talking about with the fact that you've got 1,000 agents spinning up, they all want to get their identities enrolled and they want to be given a token so they can go access a tool call somewhere through an MCP server. It's actually that initial bootstrapping of that system and getting all those agents' identities and making sure that they're all authorized to do the correct thing on some human's behalf or on some workflow's behalf in this case was actually pretty challenging. When we bootstrapped that swarm of agents, we just decided, they're all going to spin up with their own ephemeral private keys, basically. And we sort of had a notion of a very loose affiliation with a thing called a verifiable credential, basically, is how we kind of solved that problem. And that reduced the performance implications and sort of round tripping that would be required for a more federated infrastructure where they have to get that identity through some other system. And we just used workload attestation in that case to verify that, hey, this private key is being emitted from this system, this Kubernetes cluster. And we can say with a pretty good degree of, confidence that this is an okay, the policy that we're going to put around this agent now is going to be X. But I think in a lot of these systems today, we have, there's a lot of different ways that people are solving some of these problems around identity security. And it's pretty interesting hearing you talk about just the workflows and other distributed systems problems related to the space right now, because identity security is also it's a distributed systems problem. You have a lot of entities that you need to get information to and you need to get data to. It's an identity document at the end of the day. You need to get it to that workload in a very secure fashion. And you need to do it all through the process of, maybe in some cases, not having any secure introduction in place. And so you have to come up with a cryptographic means of, not only identifying, but testing what this thing might be and then applying a policy to it. It's a pretty challenging space to be in. There's some interesting ways that people are solving this today. That's pretty fun. One very recent way that I saw this being solved was through this mechanism of having like a client profile. So you have 1,000 different agents that could be running behind one single client. And that client would be given the authorization to do something. And that one client is the thing that's sort of authorized to do these things on behalf of all of these agents. And so that's that's one mechanism. That thing could be possibly a gateway or something like that. But yeah, I think that we're going to see with, the problem with these different agent architectures is that the level of productivity that you get out of them is very proportional to how long they can run for and how much the human doesn't have to be in the loop with that workflow at the end of the day. And so coming up with headless capabilities for reauthorization and reauthentication and stuff, or ways to notify a human when we do need to pull them in the loop and that human may not be at a computer at that moment. So, reaching out to mobile devices and stuff like that to get their, essentially their buy-in to say like, hey, this thing should have elevated privileges to do this now is some really interesting problems to solve in the space right now.
And actually, that reminds me of one of the first conversations that you and I had, Maxime, which is, well, in this world where, agents, again, are doing multi-step workflows, and it might require them to even talk to other agents, right? Not just, write state to certain databases as part of what they're doing. In that world, I think you and I talked about the fact that some of these workflows could last as long as, I think you mentioned a year, right? Or a couple months. I mean,
They can be permanent.
yeah.
Like I think if you think about something like OpenClaw and like this type of things, the idea is that they are running forever, right? I think the way they did not designed to run forever, right? They certainly kind of pretty naive implementation from distributed systems point of view, and it's clear because I think it's the right way to do that. I'm not saying it was done wrongly because they were innovating the feature, they were innovating the new capabilities, they were innovating the experience. And I know that people are usually don't want to be slowed down by putting resiliency there. That's why, for example, our message at our conference was that kind of right now teams have a choice. They either don't do resiliency, right, and like productization of their systems, and they just innovate, and then kind of hope that customers will tolerate the failures. And I had friends using OpenClaw and they said it needs Temporal because it just was failing all the time and hanging and all of that. And again, it's a toilet word, but I cannot imagine anyone putting that in real production like that.
Yeah.
And like other option is that you spend time in resilience reliability, but then you're slower and you can fall behind. And kind of our promise was like, if you use Temporal, you can move as fast as without resiliency, but you get the resiliency out of the box on the platform level. That is, I think, that's why we see so much adoption in the agentic space, right? Because like in the AI space in general, because people who are building startups realize that and they just use us, which is kind of interesting because we don't have any specific AI framework, we don't have any AI features, AI in our name, and we're probably one of the most widely used companies, obviously outside of major labs, right, in AI space, because we solve exactly that problem.
It's pretty interesting. There was, I want to say it was in February that Cursor unleashed, they did their own version of an agent swarm to go build a web browser. Did you read about that?
Yeah, I think I did some of that. I don't remember. I know that the Cursor uses Temporal, but I don't remember the exact use case. It could be the different one.
They observed the agents actually, coming to different conclusions about how to build this thing. So they would go and try something. They were observing this, thousands of agents essentially experimenting as they went ahead and built this web browser. And you have to think to yourself, like, okay, just from an architectural standpoint, what does it take to get this distributed system of essentially processes, right? At the end of the day, these are machine workloads. They happen to be connected to a capability that allows them to reason, but architecturally, the system that needs to be in place for them to sit there and actually experiment, I realized like, wow, this is some really powerful, not only architecturally, this is very complex, but also this is essentially, if you can teach a system to experiment on behalf of us as systems engineers, it becomes very challenging for us to then, design for what that system might need, because the experiment could, result in a new escalation to a new system or something else. And that was one of the things that really intrigued me about the access management problem with these sorts of systems too, because if those things are experimenting, they're going to ask you to get access to systems that you might not have necessarily foresaw. And I think that the outcomes of what they can build and the outcomes of what that whole process and that system kind of brings to us as an industry is a really powerful thing. But the shared state, the shared memory to actually go ahead and like have those agents work through that problem and through that experimentation, and within 2 weeks build what is essentially a very complex piece of software. That was very fascinating.
Right. As we're, at 1Password thinking about how to build essentially a credential broker in this world of agents needing access to sensitive systems, be able to, do work, right, complete their tasks within those systems. And at some point, right, state and within this example that you just shared of a swarm of agents actually be able to share state and share memory. Maybe walk us through some of the more complex examples that you've seen folks build with Temporal.
Temporal is about simplicity, not complexity.
Sure.
And
Maybe translating the most complex workflows
yeah,
to, simple kind of, as you
I,
mentioned, even markdown language.
I think, again, we have a lot of industry-specific and use case-specific complex ones. But from like AI, for the point of view, if you think about what we have in AI, we have more or less fixed workflows, right? When just media processing, for example, right? Like I've got a file, media, like a audio, video file. I want to transcode it. I want to do some other. I want to upload the results for React, right? So there is like very fixed set of steps. LLMs are part of those calls, so that's why it's AI application, right? This is kind of one area. Another one, pure agents, right? Like agentic loop, right? LLM call, model call, tool call, model call, tool call, right? And that is where we started. Now we are moving to this, what people call harnesses, right? And one thing I found that harnesses are successful when they're use case specific, right? Like, I don't think there'll be this harness which rules them all, right? I think it's pretty clear that we've got harnesses which are now very successful in coding space, because again, coding is very use case. It's a use case, very specific use case, right? And you can optimize them. But we see people optimizing these harnesses for others. One part about harnesses, especially when once you start making them distributed, is that it's not only about just purely AI things, how to manage memory, how to manage context, right? How to bring data there. Now we've got sandboxes, right? And if you think about it, sandbox is probably the first time when we actually need to actively mix infrastructure with application, right? Because usually application kind of is infrastructure like Mesos, right? Like, and then there is application which is kind of deployed. But when you write application, you don't talk about Mesos. You don't know about Mesos. You can switch Mesos to Kubernetes and application doesn't change, right?
Yeah, I mean, that's why most companies have platform engineering teams.
Exactly.
Right? As an application builder, you don't even know what's, powering your underlying IS.
Exactly. You have Kubernetes, kubectl, you have, I don't know, like Terraform, right? All these tools. And now application just says, I need compute, give me sandbox, and I want to run this code inside of sandbox, and now I want to shut it down, right? So practically you kind of start mixing these things together and very, very proactively. And we see a lot of those. Why we see Temporal there? Because Temporal was always a perfect platform for infrastructure automation. So like it's probably one of the core use cases everyone uses us for. Like starting from HashiCorp, when they built their cloud, they used us, like Datadog, all the backend, managed that. Netflix, like replaced Spinnaker with practically Temporal-based workflows. That was always the core use case. And then Temporal is widely used for application level logic, right? Like from business flows down to kind of data, whatever. And now we see the kind of both of them convergent, right? So you practically can have one application which manages kind of its own, because if you think about agent kind of, I think one shift, Wang from OpenAI, he presented our conference at Keynote, and he showed how OpenAI kind of uses Temporal. And one thing he showed is how kind of agentic architecture changes, right, from their point of view. And their point of view was that original agentic architecture was sandbox, right? An agent runs on the side of sandbox, right, and makes all these calls. Now they're moving to the architecture, which is agent runs outside of sandbox, right? It's agentic loop is kind of external program, and anytime it can request one or more sandboxes to run practically tools, which are file system tools, shell tools. Yep. But agent itself is not in the side sandbox, and it can have multiple sandboxes. And that, but it also means that sandboxes should be orchestrated. And OpenAI Agents SDK actually just released that integration, right? And Temporal has plugin for OpenAI Agents SDK, so you can run it inside of Temporal durable execution workflow, which means that your agentic loop is durable and orchestrating sandboxes is durable. So it's kind of, but I think for me, from agentic space, this is probably most complex applications, especially when you do it at scale. We have customers orchestrating millions of sandboxes practically, and they're doing sandbox life cycles for their apps.
Earlier, you said this. You used this term distributed harness when you're talking about that multi sandbox architecture. Is that what you mean by that definition?
For me, just one person doing something like is not as interesting, right? But when I say distributed harness, you can think about one agent, and again, in this case, for example, OpenAI Agents SDK would be one agent asking sandbox for itself, so it would be kind of one thing. But when you think about end-to-end platform, right, distributed harness, you kind of think about the whole thing. When you can go and say, okay, I need to work on something, right? And then it means that you go to some API. This API will run practically workflow, which will say, okay, for this specific thing, we need to start agent, right? And then maybe there is API to configure that and so on, right? And then agent said, oh, I need sandbox, right? Or sandbox says I need to download some repo, starts working on that. But then at some point, agent says, okay, I submitted pull request. I don't need this sandbox anymore, at least right now, right? Shut it down, please. And when pull request, when they need something, and then it would be interesting, is it agent through a tool, special tool, or it is a just fixed workflow, which will watch, for example, for pull request comments, right? And then comments come in, you need to maybe resurrect that sandbox, make sure that state is there, right? And then continue agent doing. So kind of the whole life cycle end to end. And then when you go next level, we talk about kind of one application, but imagine that tools and other agents and maybe sandbox infrastructure is across all your enterprise, right? This is shared infrastructure. And tool can be owned by other team. And what it means to call tool which is owned by the team. To use MCP, fine, but if it's long running tool, MCP added task, but it's still not really kind of standard which everybody adopted. So there is no, then you start thinking, okay, what it means if too many people are calling that specific tool. I need flow control, I need priorities, I need maybe fairness around that, right? So there are all sorts of these concerns about systems always fail when they are overloaded, right? Yeah. Systems without scale are easy. It's anyone can build them. At the moment, you need to start thinking, what's the behavior system when it's overloaded or something is down, then it becomes a complex problem. Like usually problems are always about scale and complexity. They arise. And one thing which changed a lot with AI, a lot of companies hit a huge scale very early, right? You remember, like the standard script was put something out, find this magical product market fit. Great, you've got customers now. You have 2 years to rewrite that to make it scalable, right?
Yep. Yeah.
Like now, by the time you start your rewrite, everybody moved on, right? Because you hit million customers in 2 weeks, right? If your AI product is successful, and we witness it all the time. Even with major labs, right? Like OpenAI, they just yesterday talked on a keynote. They usage of Temporal grew up 60x last year, right? And they didn't start from small numbers because they have almost billion users, active users, right? Yeah. And these people add up a load on their system big time.
And so maybe a question potentially like specific for agents, right? So when we're talking about these workflows, in traditional systems engineering world, right? If it fails, you just keep on retrying, and you can put in logic about, retry up to this number of times or within this window, right? Before you start all over again. For agents, maybe just to help, us, kind of frame it, what's dangerous about that, right? What's the most dangerous thing in an agentic workflow about retries?
I think the big question there is exactly at which point you stop retrying, right? Because just normal retries, and again, especially implemented properly, they're not that dangerous, especially with flow control, right, and so on. And it's kind of, I think one other thing is that usually humans decide how long system should wait for retry to happen before it escalates to the next level, right? Fails or contacts human or raises alarm, right? And usually, even if you don't have part of your workflow code, like at least expectation very frequently is that you write your business logic, and logic doesn't contain a lot of error handling code, like for these cases. It's just, okay, retry forever, right? And then usually what happens, there are metrics and there are alarms and people get paged when there are too many retries or retry for too long, and then people try to resolve that, right? Question: how do you deal with agents, right? So do you give agents ability to learn about this retry after 10 minutes and say, maybe I need to do, and also most important thing, first differentiate retriable and retriable errors. With agents, not as simple. With tools, actually not very obvious when tool fails with retriable, non-retriable error. So that is just categorizing those things is not obvious. I've seen people struggling with that. And then when error is not retriable, obviously you give it to agent. Agent, for example, it didn't format input properly. But then if it's retriable, you still fail. Then agent, what? Does it fail? Does it contact human? Does it, like, there is the whole big story around at which point humans should be in the loop and start troubleshooting versus agent can try walk around. And they are very persistent, right? So if you ask agent to keep fixing, this is a problem. They're so dumb and persistent, right? So that sometimes you just need to have guardrails because they will keep trying to solve problem in the ways which are not very productive.
Do you see them the processing that takes place there on behalf of the agent, like it's going to retry a different way than you may have guessed it's going to retry, and so you have to build the system that you're building around it, maybe the workflow itself can't really be guided by the same deterministic workflows that we thought of in the past. Do we need to modify that process in any way to account for the agent's behavior?
Yeah, I think guardrails in general for agentic systems are, for me, I don't think it solves problem in any absolute way, like in any way. Because they can be very inventive. We know that, right? Like this is how they find exploits, right? Like they put them in jail, say get out, right? And
or in our world, even if you don't give credentials to an agent, I've seen, for example, different let's say coding agents actually reach into running processes. Yeah.
Really great. We had a really great example.
They have no like they're like super persistent kind of like a clip optimizing machine, right?
There was this really fun example one of my colleagues gave. Had a coding agent, he was like, hey, you need to send an email. And so you need to log into Gmail basically. And he had second factor authentication set up. And so he got the text message and he was like, okay, well, the agent's not going to get in. Well, the agent it was a locally running agent, had access to the file system, traversed the file system, found the recovery codes for the MFA and buried in 2 years of downloads in the downloads folder and just logged in anyways.
Exactly. So I think, again, Temporal certainly doesn't help you there in terms of, because we allow your agent not to die, but we are not making it smarter. There is a lot of research which will happen there. But
well, I mean, the agents, it can, if it runs for longer, then it can be more persistent and come up with more,
absolutely,
novel ways to break things.
I think that is interesting research area. No, but I think it's exactly why people fear them. Like if they become too smart, because they can practically bypass all our security and do whatever. So yes. But again, if this kind of smart, I think smart is smarter. I think it's just the wrong way to even think about them, right? Because capabilities to achieve certain results are there and they are growing, but smartness is not there.
Persistence and resourcefulness aren't the same thing,
right? So they certainly don't understand why they're doing things, and should they stop doing something because it doesn't make sense. But I think this error handling in the agentic world is something which will be, I think, area of research, because when do you stop retrying? What it even needs to stop retrying? Should you invoke humans? One thing I found, like, with my coding agents, I found that I cannot trust skills. They ignore them left and right. And I almost always end up doing hooks. Almost anything which I want the agent to actually do, it's always a hook. It's it's hard boundary practically. It's a script. It's something which will stop operation in the way. Like if agent did something I don't want to do it, I don't put it in the skill. I try to create a hook if it's theoretically possible.
That's actually really good insight. I'm probably saying the same thing, because actually we've developed essentially both skills and hooks. For example, don't leave any credentials lying around in plain text. Don't save any credentials into your local disk. So I actually be very curious to see kind of how our users adopt that in the wild.
Yeah, that's true. Absolutely. I think one thing which is what I like about recent developments of that notion of plugins, right? Because they install your plugin and then you decide what goes in plugin. Is it hooks? Is it skills? Is it whatever? You can change it with time. And people don't need to kind of think about it. They just update your plugin, get better functionality. So I like that because we certainly also started from just simple skills, and we see a lot of adoption of skills because temporal code is a little bit different than like standard code, right? So there are certain rules, and skills help agents actually follow them, and people can one-shot pretty complex applications. But next step would be a lot of kind of validation, like hooks, linters, and like static checkers, and so on and so on.
So tell us more about the demo that you wanted to show our audience today.
I think I just want to show simple one would be the one I really like. This I mentioned release of OpenAI Agents SDK. These sandboxes. Just what I want to show is that how easy is that setup to manage sandboxes, because they already provide integrations with sandbox providers, and it means that and as temporal agents are automatically passivatable, so practically you don't need to run any compute to when agents is waiting. So you can have millions and hundreds of millions of, like, even if you run on our cloud, billions of them in parallel. And if they're waiting, they're not consuming any compute resources. But the moment there is a new event or timer or like a reply from log-running operation, it woken up agent and decides what to do. And if agent says, no, I need to run some activity which requires sandbox, it will execute that code in the sandbox. And then there is the whole sandbox management, because you can say, okay, if I didn't use this sandbox for some period of time, it will shut it down automatically. So there is the whole lifecycle management there. And it comes as part of the OpenAI Agents SDK framework, but Temporal allows to run all of that resiliently. So it means that you can run this at large scale in the cloud and make sure that that system is fully fault tolerant and robust and scalable. But I think that is a demo. I just want to show how it looks in real life, and we say our UI and obviously demo UI as well.
Maybe you could chime in with some of your recent experience, building integrations with sandboxes. And
Yeah, I mean, we firmly believe that I think the future of productivity for the enterprises with AIs, and especially with agents, is probably in the sandbox environments. So we've been doing integrations with the folks at Daytona, Vercel, with their sandbox environments, the foundation model companies, the security controls that your local system has. I think that it's really interesting when you mentioned OpenClaw earlier. It's one of the primary things that we've been working on trying to solve, is like, how do you secure the system that's on your local machine, essentially? And one of the scary things with AI agents is that a lot of people end up giving the file system, the agent, access to their direct file system. And it's essentially akin to walking out on the street, handing a perfect stranger your laptop and saying, have at it. And what's scary about that is that I think a lot of people have sort of, and I believe companies as well, assumed that the endpoint's a pretty unsafe place, but we end up storing a lot of clear text credentials on that endpoint. And when you give something like, an AI agent that runs on the CLI, just direct access to that file system, it can suddenly access everything in the downloads folder, everything in your dot directories, all your configuration. And now that's all in agent context, and, everybody's pretty unhappy about that. So I think that, coming up with ways to sandbox that agent and where it's running locally, building, you were talking about harnesses earlier. I view the web browser as like a form of a local agent sandbox. But up in the cloud, the process of getting all of that, secure information about what credentials exist, or even, let's just say, a simple broker credential, right? Like an OAuth token to an agent harness in a secure fashion, is a pretty challenging thing. The harness itself, in some cases, you can trust it to be able to, maybe consume a credential and not pass that off to the context that the agent might have a feedback loop with an LLM context. Other harnesses, you might not be able to trust that they can actually do that in a way that's not going to exfiltrate something. And so the only way to control for that is to run it in an environment where you have complete control over what the agent has access to, and just assume that things that enter into that environment are going to be completely insecure. And so we've done some really fun integrations with, I think the work that we're doing for Vercel and with Daytona in particular is pretty compelling, because it allows us to actually take, just a simple reference to a credential in a 1Password vault and resolve that inside that sandbox in a completely end-to-end encrypted, zero knowledge way.
Yeah, I absolutely believe that.
yeah,
we should never pass these tokens through sandbox. And at least I remember, like, I'm not a security expert. Like, this is an area where you guys pull me out of the water completely. But I remember, like, Amazon has this way to do that, right? When you access AWS resources without ever passing credentials, right? Like, just
Service link rules.
yeah. So I think we need something like that for the industry everywhere, right? And ideally we should some sort of standard, right? And you guys should be just plug the standard way. And I don't know if MCP is the right way to. MCP is about different thing, right? So we need more like invocation level kind of like CLI.
I think the MCP spec kind of just avoided that topic altogether.
Yeah, we probably need to. And for me, MCP is not because it looks like we are converging more and more, at least in near term, on CLIs.
Yeah.
Right. For example, we decided to invest in CLI much more than having our own MCP server, because CLI already provides a lot of capabilities, and the LLMs just work better with it. And but it also means that our CLI needs to be authenticated, and I don't think there is there is no, if it would be something like, oh, CLI, am I running inside of sandbox? Okay, here's what I'm going to do, right? And there is this very standard API. That would be, I think, awesome, because then we solve that problem 100%.
Yeah, there's some interesting ways that I've seen that being solved. One way with at least the 1Password product is through a shell extension. So you can actually build a wrapper around an executable on the shell that allows you to transport securely a 1Password vault item to that executable. And they're built specifically for that executable. So you write a shell extension for, say, the Claude CLI. The interesting thing with MCP and MCP servers in general is that because it's essentially this networking protocol, you can build a gateway around it, and you don't have to actually transport the credential to the environment the agent's running in. You just have to worry about transporting the credential to the MCP gateway that the agent is communicating through. And then that gateway can inject that credential securely. And that gateway doesn't have to actually be, running in the cloud or remotely. You can have that gateway running locally on top of the sandbox. And that way you can kind of be free of, you don't have to worry about, did the developer code this in a specific way to consume a credential securely? You can kind of leave all of the security guarantees to the sandbox and the networking layer, and, make that developer experience pretty transparent.
That is awesome. But again, it looks like more people are moving CLIs now.
Yeah, totally.
Yeah. So, I usually want to sort of close on, favorite question that we like to ask our guests, which is, if you could build anything you want over the next month, what would that be? It could be temporal, but it could also be something else.
Interesting. At least in Temporal, one thing which we are, there is a project which I just want to finish today, right? But it will take some time. We call it Nexus RPC. And idea is that, as I said before, event-driven systems don't have no interfaces, right? But you still need to have long-running operations, right? And you cannot just say, use workflows. It's a kind of weird way to solve this problem generically for everyone, right? So our idea is, can we have standard RPC protocol for long-running operations, right? Which is not temporal specific, which is more like just standard way to do that. So, because if I come to 10 developers and say, I want to implement this operation, which takes 3 hours, how am I going to model that? Will be like 10 different solutions. Why we just cannot standardize on something, right? We have webhooks, we have notifications, we have queues, we have whatever. Can we just say, okay, this is standard way to call operation, get notification, learn about its status, cancel it, and whatever. And when we can do bindings to protocols, it doesn't need to be even protocol specific. We can just say in HTTP, you can implement it using webhook, and this is how you do that. Or you can do long poll, this is how you do that. Or you can use gRPC, or can use Kafka to deliver results, right? But do it more or less standard way. And obviously it absolutely fits tool calling, but in this case, I would just say this will be transport layer for MCP, right? If you think about that, there is already a RPC protocol for long-running operations. You just say, it's a MCP kind of has pluggable transports. We just say, it's another transport, and now MCP magically supports long-running operations, right? Long-running tools, because we want long-running tools. That would be the project I would say I want to have today everyone using, because we are already building for Temporal. We have practically, it already works within our ecosystem. But what I would love to is kind of speed up the process of us getting to the point when we can talk to everyone and make everyone adopt that.
So
love it.
that's like a system without any retries, or it's just
No, it's a built-in, because the whole idea is that, and again, you can think about different quality of service levels, but the long-running operations without guarantees of delivery make no sense, right? So the whole idea of this protocol would be that it's not only operation can take long time, it also guarantees that delivery of that operation is guaranteed. So internally, it will be obviously all queues, webhooks. Again, we are building on top of existing technologies, but we just elevate level of abstraction from okay, bunch of WebStar queues to long-run RPC.
You know, what's interesting is that I'm sitting over here in the security domain, you're sitting over there in the distributed systems domain. And in both worlds, we are essentially building on top of, and in many cases, abusing the existing tools that we have, the existing protocols that we have to make these systems kind of work, and thinking about all of these new ways that we can, extend those existing protocols to, make them function for us in this new world where we have these long-running autonomous workflows.
Mm-hmm. 100%.
Well, I'd be excited to see that in real life. Yeah, and I feel like we, could certainly continue this conversation for many, many hours. But I just want to say thank you so much, Maxim, for joining us in the studio today.
Thank you.
Hey, Maxim, thanks so much for joining us. I just want to, welcome you back to the recording studio. I know we spoke a lot during the live interview about the work that you've been doing at Temporal as a co-founder and CTO. And so, wanted to welcome you back to demo something super exciting, a recent launch that your team has done. So mind giving us a quick intro on what you're about to demo today?
So thanks for having me. I want to just show you a pretty simple sample of a chatbot which invokes tools, and it executes those tools, especially shell commands, in a sandbox. But as I said, that sandboxes are kind of became part of your application, which manages practically at this point. Your harness is not just kind of application which invokes LLM and tools. It also has to provision infra, because sandbox is partly infra and you're mixing them in one place. So OpenAI Agents SDK recently added sandbox integration, and Temporal already integrated with OpenAI Agents SDK, which made it durable, because OpenAI Agents SDK is just a Python program which runs in memory. But with Temporal, it became a durable workflow, so which means that it preserves all the state, and any part of your application can fail anytime. So like process can crash or machine can go down, but the actual durable event loop stays durable, so you don't lose data. And also it provisions sandboxes to execute dangerous operations. So this is what I wanted to demonstrate.
So would you say that this is a core separation of, essentially compute, right? And also all the other processes? Like maybe walk us through, why you've designed it that way.
So a couple of things. Sandbox is not cheap, right? So especially if you have a very large number of agents running in parallel. But you have to have them because otherwise you would have appropriate security. So the idea is that you run sandbox and it's active only when you need to run these dangerous commands. But for example, when your agent is waiting for user input, which can be pretty long, right? So human can come back in like 20 hours. And you don't want a sandbox run for 20 hours waiting for that. And we don't want to be in a situation where people are buying like separate Mac for every agentic loop. So the idea is that agentic loop can run in a separate process, and then you can have a lot of them running in parallel. With Temporal, especially if the agent is passively waiting, there is no overhead. So you can have billions of agents running in parallel using very small number of processes, and only start sandboxes when they need to execute specific commands. That is the idea. And also it allows you to add durability more easily. So because you can separate out the durability of the agentic loop and then durability of the file system and sandbox, they are becoming kind of separate concerns.
That makes a lot of sense, to be able to essentially chunk up different processes and be able to parallelize different processes. But we'd love to see it in action.
So here I have a simple sample when I have coding, kind of small coding agent. So let's ask it to generate some code. Let's say, let's generate hello world in Python. And it's pretty primitive, has some pretty basic shell tools, but it kind of demonstrates the idea. Okay, generated, we can find it here on my local machine. And you see it's pretty simple Python program, right? But let's do something interesting. Let's switch to a different backend. So let's say we were running locally on my machine, and now I want to run this command Docker. And I will say, okay, change to hello Docker. And it will start running this command. And we can bring Docker dashboard. And you see, it just started the container inside of Docker to execute this command. And okay, and it shuts down container after executing the command. And obviously you can manage lifecycle, like you can cache these machines, you can make them run longer, but in this case, it just shuts it down after the command. And it kind of printed hello Docker when it was executed. By the way, if you look into the original place where we did that, it still says hello world, right? Because actually when we were shutting down this kind of local development environment, we executed command to take snapshot of the Docker, practically the environment file system, and saved it. And then we reconstructed it in the new Docker image, changed that, and executed that, right? So it's only made a local change in the Docker image. So now we are still running on my machine because it's Docker.
Yeah. So would you say maybe for the audience, the key value capture here is that you have essentially a consistent runtime, right? Whether you're in, Docker containers, which you just showed us, right? Whether you're local and even, for example, when you're saying like, hey, let's change the backend, it's a consistent runtime experience for the end user.
Yes, it's a consistent runtime. Also, user really doesn't need to think about where this agent is running, right? Because this agent is running as let me show you. I have this process.
That brings up the question, Maxime, right? Is now that you essentially are abstracting away, right? You're building essentially this layer of abstraction over, I guess different backends, right? Different environments, local, remote. How are you thinking about things like observability, right? Because when you have an agent, hopping around all of these different like environments and processes, like, how would, for example, an end user think about like debugging or replaying certain agent actions?
Okay, you see, I brought this window of temporal UI into the view, and
Yep.
actually,
You
it's a direct
anticipated
answer
my
to your.
question. Yep.
Yeah, it's kind of directly because temporal logs everything which goes on into your agent and in your application. So in this case, we practically you see the whole session is recorded. For example, it was using local sandbox, right? And you can see all the commands which were going to that sandbox. And then it had the Docker sandbox, right? So it practically said, okay, we need to start the session. So it will have input to the commands. We will have which snapshot to use and all this other information about your Docker image. And it's all recorded, and you can look at that. And this is the message which I sent, for example, change to hello Docker, right? And it started to execute Docker commands. And then you see the last command was delete Docker image because we kind of finished the command. So everything is recorded and everything. And let me show you other thing is that I can kill the process. This is at the bottom, the process which runs the workflow, right? So which actually runs the agentic loop. And so if I try to ask something, um, change back to hello, you see it's got my message. So it's got message change back to hello. but nothing is happening because the process which actually executes this logic is down. But the moment I bring it back, it will go continue executing as nothing happened from the same point. So it's because it's the full state of the agent is persisted inside of temporal, it will just continue executing as nothing happened. And this is the power of temporal, is that your infrastructure can fail anytime. But if you look at the code, and we don't have time, can you go deeper into the code? But if you look at the code of this agent, it doesn't contain any crash recovery logic. It is the same OpenAI agents SDK, which was written without any crash recovery in mind, but it comes out of the box with all these features because using temporal. So you not only don't get it's this graph. It's not only about visibility. It's not just for human consumption. It's used actually to recover state, and you can have this state. So that is, I think, what's important.
Got it. So essentially, you've essentially moved the entire debugging story into temporal and away from the sandbox or whatever environment it happens to be running in. Yeah.
Exactly. Sandbox becoming just a way where you execute certain commands, but actual full state and debugging and scalability, like human in the loop, all these things become part of the temporal story. Also, this UI is talking to temporal server. It doesn't execute any commands directly, so you can kill it and reconnect anytime.
So the temporal server essentially becomes a control plane.
Yes. Okay. It becomes more like a coordinator in a sense, but code still runs on your premises. So control plane is still the application which we killed here. So one other thing I want to show you is that you can actually switch that to, let's say, Daytona, which is cloud provider for sandboxes, right? And if you do and say hello. And you see, Daytona sandbox was created, right? And it now executes this command in Daytona. And again, it took the snapshot which we took from my Docker. So you see, and the session continues, right? It's still the same workflow, right? I still got my command. Now you see it's actually executing Daytona commands, right? Daytona sandbox session starts, stops, or down. And now it's down, right? And everything is recorded. And this agent now can wait for my input for the next few days, and there are no really resources used, especially if your UI is disconnected. Other thing I want to show you is that let's say we shut down our worker, which keeps this code, and we go and let's say we simulate failure. Let's say just a second. So I just put invalid API key for Daytona, and I run this worker, and I will ask it, okay, go back to world. And you see it's throwing failed invalid credentials, right? So this is error happening. But usually this is distributed systems. These processes run somewhere else. But if you go to Temporal dashboard, you will immediately see, oh, okay, Daytona sandbox client, right, is failing because the invalid credentials, the whole stack trace of the error, and it's been retried using exponential backoff. So you have full visibility. So it's very easy to troubleshoot these things. And let's say that was intermittent problem. So in our case, we will just restart this worker with correct credentials. And on the next retry, it should really go and okay, you see, it went through, right? And we have the sandbox running. So you can control the timeouts and retry policies. But basic idea is, look, what happened is I killed the process which actually hosts this code died, but then it was misconfigured when we restarted it. But your session keeps going, right? And that is kind of the basic ideas. Temporal allows you practically write agents which are durable, which don't fail, which can run for a very long time, don't consume resources when they're down. And with OpenAI Agents SDK sandbox integration, we can execute dangerous commands in sandboxes, but only use sandbox when it's needed. No, and so practically don't pay for sandbox while you're waiting for any other tool or user input. That is kind of high level overview of that.
Wow, this is super cool. I think, especially, I'm sure, as more enterprises and your customers are deploying agents in production, right? The environment or the runtime is going to change. And so I think having this central, call it like the brain, right, nervous system of how to debug. I think, I would be curious to understand, right? In this case, you went sort of cleanly from, Docker to Daytona. What about in scenarios where you have like them running in parallel, for example, or in cases where, let's say, the failure, like you showed a incorrect credential, failure use case. Maybe there's like flaky tools as well. So curious to see how like all of those error cases show up in Temporal.
So I say it will be exactly the same because these all external API calls, like LLM calls, tool calls, management kind of any other management operations, like in this case, sandbox management, are modeled as we call activities, and they are retried by default. So if these things fail, the only work you need to do as a developer to differentiate retriable, non-retriable errors. Because, for example, in this case, we treated invalid credentials as non-retriable, as a retriable error, but sometimes certain errors are not retriable. And it's interesting because in the context of long-running agents and long-running applications, what's retriable, not retriable is different, right? Because in normal application, if you're making a request and you get bad credentials, all you can do is fail. Retrying doesn't make sense, right? Your credentials will not be fixed by your process in 5 seconds. But if you have something which is runs for a day, you absolutely can provide a fix, and a lot of errors which are usually non-retriable become retriable. But some of them are, like for example, I don't know, if you're making money transfer and there is no enough money or it's wrong account ID, you probably don't want to keep retrying that forever. So that is as errors. They appear exactly the same way they retried, so UI experience will be the same. And then what was the first question? I think I missed that.
I guess the first part is, yeah, when you have different environments running in parallel, right? Because this was like, I mean, very nicely like sort of start, stop, sequential. What happens when you have multiple workers, let's say, running in parallel in different environments?
So first, couple of things. What we have worker here is it just process which hosts agentic code, and then we can have a lot of them running in parallel, and you can kill any of them anytime, and this state will be migrated automatically to another machine. So that is comes with Temporal out of the box. But at the same time, there are other scenarios. For example, when you have agents which belong to different groups, and these agents needs to communicate, or tools which belong to different teams. So practically, if you can start thinking about service-oriented architecture. And the problem with current service-oriented architectures is that they are not really friendly to long-running requests, especially if you think about things like tool invocations, long-running RPC. You have very nice interface of your service with operations defined, timeouts defined. But then you say this operation can take 3 hours, and you cannot have an interface. You're kind of forced into this event-driven paradigm. And this is what the Temporal fixes out of the box, because Temporal allows you to define long-running RPCs. And you can have kind of durable RPC, which can take a few hours or even days. And it maps to tools very, very well. So now you can have long-running tools. Or you can have sub-agents which run for a long time, and you can wait for them for their completion practically synchronously, or you can run multiple of those agents in parallel. So it becomes very easy to model sub-agents in distributed systems because all of them still have the same durability guarantees, and parallelism is very easy. So you can absolutely run a lot of them in parallel, and scalability is practically unlimited. If you want to run billions of agents in parallel, you absolutely can do that if needed.
Well, that was the agent swarm, sort of use case that I'm seeing across, especially across DevOps, right? SRE use cases in companies. I guess one maybe final sort of concept, right, that probably comes up as well for you as you're designing these workflows is item potency, right? Especially around long running workflows is, let's say, especially around like retries. Like how do you sort of avoid, sort of retries side effects, let's call it, right? When idempotency is important design consideration.
So as any distributed system, the reality is that you have to make API important. Because if you're calling a tool, there is always probability that tool will complete execution, and then the acknowledgement and result will be lost in traffic, right? For example, due to network issue or process crashing. So, which means that actual operations which you are calling must be idempotent. Temporal has some support for non-idempotent, mostly in the form of at most once operations. So you can call operation and say, either execute this operation, return me an error. So, and it will guarantee that it will not try to execute it again. It will just return error. But one problem is that if you got error, you don't know if operation succeeded or not. So then you need to you can run some other operations to kind of validate if it succeeded or not. So that is kind of, you can mimic idempotency on a higher level. But usually I would say every operation which calls external APIs, and these APIs have to be idempotent. I don't think there is a good way around that.
Yeah. So living proof that even in the world of agents, we still have to, remember how to build scalable distributed systems.
Yes, 100%. I think agents are, but I think with what we are seeing that these agents, agentic systems, exactly from local, simple, like single process programs are more and more resemble real distributed systems. And I think with agent swarms and sandboxes and all this management of sandboxes, they're becoming practically very large distributed systems. And I think this is where Temporal plays, because while we were experimenting with local Python programs, yes, you didn't need Temporal. But right now, once you start productizing those systems, scaling those systems, adding resiliency to them, you need something like durable execution to practically run these things in production.
I couldn't agree more as a systems person myself. Um, Maybe one word of advice for customers who are going to be trying this out in their production systems. What would you sort of advise them to do?
As anything, I think you just do it iteratively. So Temporal is this way to write your code, and it has integrations from OpenAI Agents SDK is one integration, but we integrate with a bunch of other SDKs. And pick your SDK or write your own, but make sure that you don't only focus on the kind of AI part, like LLM part, but think about, again, that the moment you deploy these things in production, you're dealing with large-scale distributed system problem. And don't forget about that. And obviously, if you use Temporal, we can take on most of the burden of those complexities.
Great advice, Maxime. Well, thanks so much for coming to the studio again and walking us through this demo. I can't wait to try it myself.
Absolutely. Thank you.